Hi, I'm Tom Dean. I'm a field engineer with Buoyant, and we are the creators of Linkerd Service Mesh, and Phil Henderson is here with me. This is our first time presenting. Please be gentle with us. And right now we're scared out of our wits, but we'll be okay. Show of hands. How many people here in the audience are Service Mesh users? Cool. Linkerd users? Few? Cool. How many people run in a multi-AZ setup right now and with their clusters? How many people are paying a lot of money for cross-AZ traffic? That's what I expected, right? So today we're here to talk a little bit about cross-AZ traffic and really focus on kind of, what the impact of that is and how you can leverage topology aware routing to avoid that, and how you can use a service mesh to kind of keep an eye on what topology aware routing does and understand what's happening in your cluster and address certain scenarios. This is based on a blog post that I worked on with William, our CEO. If you'd like to go ahead and dig down and read that, you can scan this QR code, or you can go up to buoyant.io and look for the blog section, and it's in there. It's pretty recent, a couple of months back. It shouldn't be hard to find. So it digs in. We did a little bit of research, wrote this up, and talked about some ways to mitigate it. So before we start, reliability is the first duty, right? And this is why we're using service meshes generally. It's going to give us security. That's with us. Our experience has been MTLS is the gateway drug for most people when we're talking service meshes. They want to mesh. They want to get encryption in flight. They want to make sure that their traffic is secure. But another big thing for customers is observability. You can consider observability and metrics kind of the same thing, but they're not. There's a lot of overlap. And the reason that's important, and it's important in this talk, is that we want to know what's going on with topology aware routing and with our traffic in general, so that if we witness a condition that's strange, or maybe we don't witness it at all, we need something to tell us, hey, something's hinky here. We really need to kind of look and see what's going on. Performance is another advantage. Topology aware routing is great, but when you put Linkerd in the mix, we're going to get this power of two choices, load balancing, and I'm not going to go deep into it, but we look at two endpoints. We pick the more optimal endpoint. So even with topology aware routing and everything else, we're going to pick one that is more favorable, so you're going to get a bit of a performance boost, and things are going to be a little more smooth with regard to traffic and latency. Keeping traffic in zone. So what are failure domains? There's three big failure domains we want to talk about. The first one is your cloud provider, or on-prem, whatever you want to consider that whole thing. That's kind of the most global. Using topology aware routing is not going to fix that. If your cloud provider goes down, that's not going to prevent anything. The second is regions. Again, we're not talking about regions. That's something you have to consider kind of outside of the cluster. But the one we care about is the zone, or the availability zone. Kubernetes knows about that. There's a label on your nodes that tells it, this is where I am. This is my zone. Maybe US East 1A. It could be something that you put in if you're running on-prem. So that's what we're focusing on is the zone, or the availability zone. And generally, like if you're running, say, EKS, you're probably going to spread across three of those. And like we said, when you start to run traffic across zones, there's a cost associated with that. And we're going to talk about that here in a second. So how much does it cost, right? If you take an example of an EKS cluster in 3 AWS availability zones, these are the numbers. So if you've got a measly 1K, you're like 40 cents per year. Who cares? We don't need to worry about this. But if you're a common customer that we see, 1 gig a second per average, that's 410,000 per year. Do the math, divide that by months. That's almost $40,000 a month, and that's considerable. Plus the cost of latency. Anytime you jump between data centers or between zones, you're going to have a latency cost. So, if you can keep it in zone whenever possible, that's going to give you a little bit of a performance advantage. And like I said, again, then using Linkerd, you get that power of two choices, load balancing. That's going to also give you a bit of a boost too. So what is topology aware routing? It used to be called topology hints, right? It's been around for a bit, part of Kubernetes. It is a way of doing connection-based routing to tie your clients in one zone to your resources, your endpoints in that zone. So we keep traffic. It's hardwired at the kube proxy, and it's a very straightforward way to keep things Enabling it is literally an annotation. Disabling it is removing that annotation. Pretty quick and easy to use. So what are the pros? It's a feature of Kubernetes. Nothing to install, nothing to activate. It's mainstream enough now that you don't have to go and enable anything. You just put that annotation on and you're ready to go. Another pro, keeps traffic in the AZ, right? So that has some cost and latency advantages. And cons, you're going to need at least 3 endpoints per zone. So you need to definitely consider that when you are designing and implementing your services. The more endpoints you can have per zone, the better, to a point, right, obviously. But running with the least amount of endpoints will bring you in and out of topology-aware routing if you lose just one endpoint, right? So you want to try and have some extra endpoints so that if you lose an endpoint, it's not going to kick you out. Topology-aware routing is not aware of in-band failures or problems like HTTP 500s and whatnot. So we're going to show you. It's going to keep just doing what it does because it doesn't know that those are happening. And it kind of interacts poorly with features like HPA. We're not going to demonstrate that here, but if you want to look into that, you want to play with that yourself, you'll see that it really requires kind of a stable state. You need to consider your traffic and your design so that you've got things spread somewhat evenly, right? It's not very dynamic. It's connection-based routing, not request-based routing, right? So it doesn't adapt with each request. It really is just hardwiring your service, requesters to your endpoints and your services in the back end. So how does topology-aware routing work? This is straight out of the blog. I shamelessly poached it. Like we said, Kubernetes feature designed to address the cross-AZ problem. It basically takes it at the network level at kubeproxy, and it hardwires those connections together and says, look, these are the endpoints you're going to use. You're a requester, your client, you're in this zone. These are your endpoints. How does it interact with Linkerd? Linkerd's destination controller respects that. So when we are choosing endpoints, we will defer to topology-aware routing as long as it's enabled. So we don't try and do anything, right? And we're going to show, like, what does it look like with just Linkerd when we add topology-aware routing, what happens in certain scenarios. So let's talk about, this kind of covers our application that we've got, and it covers how it works. But right now we've got a application that has 3 orders, deployments, one in each zone, and we've got 3 warehouse services, and we have 1 in each zone. We've got 3 replicas of each, so we've got 9 total clients, 9 total endpoints for the service. And right now, without topology-aware routing, everything talks to everything. So if you think about that, for each client, 1/3 of the requests are staying in zone. 2/3 are going out of zone. So, you would basically, 2/3 of your traffic for each client is going to cost you money if you're paying to run that traffic across zones. When we enable topology-aware routing, we hardwire those connections. We've got connection-based routing. Traffic stays in zone, pretty straightforward. If you've got things balanced, it works really great. Health checks. So I talked about this a little earlier. In-band versus out-of-band. So in-band health checks, Kubernetes is not aware of these, right? So because Kubernetes is not aware of your in-band health checks, it is not going to respond if all of a sudden we're getting HTTP 500s. It doesn't know. It's like, okay, all the endpoints are up. We're good. Let's keep sending traffic. Traffic is flowing. It thinks everything's great because it's only paying attention to, do we have enough endpoints? Are they reachable, right? Out of band. This is where a service mesh is going to help, and where you start to talk about things like request-based routing. It's going to be looking at things at that layer 7, and if it detects something that's amiss, it's going to say, oh, I better do something about that. But with connection-based routing, it doesn't know that. It just knows, are my endpoints up? Do I have enough endpoints in each zone? If it doesn't, it's going to disable itself. All right, I've talked enough. I wanted to hustle through the slides because I know all of you are betting on whether our demo is going to fail, and you want to get to the action, right? So we're going to walk through a demo. We're going to show 3 scenarios where we have some failure modes, and in-band and out-of-band, and let's see how Linkerd handles it initially, and then let's see when we enable topology-aware routing, what the results are there. I'm not here to bag on topology-aware routing. I'm just talking about one of the bigger things is, why observability is important, right? because it's a pretty straightforward feature that you kind of got to keep an eye on, because if things go amiss, then you might need to understand what's happening to fix it.
All right, everyone say a little prayer to the demo guys before this talk. I was struggling with my MacBook as throttling all my pods, so let's just hope everything goes well.
First scenario is latency. So what happens when we inject like 600 milliseconds of additional latency into our application?
We'll go through metrics first.
Oh, yeah, metrics. Sorry. We're going to talk about metrics and why it's important.
Just give you an overview of metrics and what they look like and how we can use them as observability tools. So first we're going to look at all of our metrics that are available. As you can see, there's a lot of them available. This is for the 3 pods in one of our deployments. Obviously, no one's going to go and read through all these. I couldn't even tell you how many of them I actually know here off the top of my head. If we look at how many there are, there's almost 2,000 unique metrics for those 3 pods. That's a lot of metrics. That's hard to go through.
Yeah, that's a single zone.
A single zone. But with Linkerd Viz, we can view those things in a nice, easy format. We can get our success rates, our requests per second, and all of our latencies that we would want to know, our golden metrics, as they call them. And it also kind of has it based on routes. So you can get your probe routes and your default routes, which could be important for people who want to make sure that they're not looking at their probe metrics when trying to do their business logic.
Now, additionally, there you could define HTTP routes and split the stuff in the default out, so you could observe traffic to specific services or services that are available. But we're just kind of keeping it simple, right? All the traffic's in one big default bucket.
Yeah, and we can still use Linkerd to start getting stat outbound on our deployment and see how that traffic is going. And we can still get, again, our success rate, requests per second, and all of our golden metrics that we like for latency. And it's nice when you can use a little grepping and like get some of that information out of there, right? A little grep magic always helps our lives, right? Who in here knows Linux a little bit, right? All right, and you can see that we have all of our endpoints. As Tom was talking about, we have 9 endpoints for topology aware routing that we are required to have.
Yeah, it's important to note that, right? You want to understand how many endpoints do I have? Are they healthy? And so we have some commands that, and some stuff. You can also leverage kubectl. There's some good commands we're going to show here. But understanding what the status of your endpoints and where they are is pretty important, when you're using connection-based routing.
And I'm someone who loves the command line, just how I've always been, but sometimes it's easier just to go to Grafana, right? We all have used Grafana, most of us have, or some other visualization tool, and we can easily see our statistics here. Make that a little larger for everyone.
So we have a dashboard. I use this a lot because I'm kind of the zonal guy, right? And so the 3 panels that are kind of important, at the top we've got in zone, out of zone. That's your green and red lines up there, and it'll tell us where the traffic is. And right now, what is it? In zone, same AZ is red, and cross AZ is red, and same AZ is green. Underneath that, we have success rate. That's important. We want to make sure that our service is successful and that our traffic is getting where it needs to go and it's coming back. And then there's latency to the right of that. And latency is pretty important because, obviously we want to see that we're not, struggling with regards to latency in one zone or any particular zone.
Sorry, fam. So that was demo 1. Now we're going to go into some scenarios.
All right, now, I'm not going to jump the gun. In the first scenario, we want to take a look at the effective latency. And we're going to inject 600 milliseconds into a single zone. It's the west zone. So that comprises our west orders and our Oakland warehouse.
So we injected our latency, so 600 milliseconds for the warehouse. And we can still see that we have all of our endpoints, all 9 endpoints. And we can still see our statistics. Everything is at 100% success rate, and we can see that, we're seeing our latency being load balanced across all 3 of our warehouses.
Yeah, remember, we've got 3 requesters, 3 warehouses. So right now, everything's talking to everything. So latency is only impacting 1/3 of the requests for each client.
And to add a topology aware routing, it's as easy as adding an annotation to your services. And it's there. And you can check it by, getting a git grep for your annotation. You can see that it's there. It's on auto. And you can also see it in events, which is nice and helpful if you like to look at events.
One thing to note is sometimes, especially when it falls out, it might not show up in events immediately. It can take a while. So again, having additional ways to measure success or to measure impacts is pretty important. Again, that's why observability and metrics are kind of key when you want to use topology-aware routing.
And again, we still have all 9 of our endpoints. It's all about the endpoints.
Yep, connection-based routing, as long as we've got enough endpoints, it's going to be happy.
So what does our deployment in the West look like? We can use Linkerd Viz to, again, see all of our statistics of success rates, requests per second, and of all of our latencies. And you can see everything's kind of being now to that one zone.
Yeah. If you got all the latency contained to one zone, someone might ask, is that a good thing or a bad thing? I don't know. Depends on your application, right? It depends on your traffic flow. But being able to understand kind of what the impact is important, because then you can start to apply that to your specific needs and your application's needs and decide whether that's a good thing or bad thing and how you're going to address it.
Yeah, if you're using GSLBs, to where you have people on the East Coast where their connections are fine and you're just only degrading the West Coast. So, there's a scenario as well where, you can have where some of your traffic is still being completed, you just have one region still being affected.
So what does this look like in Grafana?
Oops, sorry, fam. So we can see that now we're no longer spending money, but we can see that, again, our latency in the West is there, because that's how topology-aware routing is going to send our traffic.
We're still at 100% success rate, so we're good. We don't have enough latency to start impacting that, so we're healthy. We've responded well, right? If you were to inject a whole bunch of latency, we would probably see success rates going down in that single zone, and obviously our latency graph would be through the roof. But we didn't kick this thing too hard. It's performing pretty well. But again, understanding and seeing what's happening is very, very important if you want to manage this thing, long term and have control over, what's going on in your applications and environment.
We're going to go ahead and reset our warehouse, make everything healthy again.
Yeah, we don't want anything to bleed between these.
And to remove topology-aware routing is as simple as just, running your kubectl annotate and just deleting the annotation. If you're familiar with that command, just put a minus on the end. And we can check our work. We can see our annotation's gone. We're going to check events. And we can see that even in events, it tells us that it's now disabled. So one thing you may encounter is a partial failure in a single zone where you could have only half of your application responding with 500s.
Yeah, say you had like a failure in the back end or in middle tier, but your front end is still responding, but half of the responses are 500s going, no, I can't serve this. So this is not really a site outage. This is an application impact, and this is what we also consider an inbound failure condition, right? Or an inbound failure condition, something that topology-aware routing might not pick up.
And again, we still have all of our endpoints, all 9 endpoints. So what does the stats look like? We see in Viz that all of our success rates are going down because it's being spread across all of our regions.
Yeah, without connection-based routing, we're going to spread that around. But, the success rate's pretty high. I don't think depending on your application, you might not even notice this if you didn't have observability. But with observability, you can see that things are starting to be impacted and get ahead of the curve on it.
Oops. So let's see what it looks like in Grafana. So we can see our success rates going down all across all regions, because again, we don't have topology-aware routing enabled, and it's being spread across all of them evenly.
You can also see the latencies coming back down, right? Because we got rid of that. So it's nice to see recovery from failure conditions as well.
So let's go ahead and again, add topology-aware routing, simple as adding an annotation. We're going to go ahead and double check our work. Make sure, I always like to double check. We can see it's there. We can look at our events. We see it's enabled again. And again, we can see all of our endpoints. So what does it look like in Viz? So now we can see our success rates going up in the other regions and it dropping in the one.
So again, we're containing the issue into one single zone because connection-based routing, right? We're plugged directly in. And, again, you have to decide with your specific application and everything and your environment whether that's a good thing or a bad thing. But it's expecting as we would, or it's behaving as we would expect, right? It's keeping that in zone, and you know, it's again up to you whether that's good or bad, but it's very predictable.
And what does it look like Grafana? Again, we like to go back and have nice little visuals. We can see that everything is going up in the other regions as our success rates, but in the central, it's just going down still. So everything is now pinned to that with Topology Aware Routing.
Yeah, and you can see, right, it's keeping things in zone since we've turned it on. If we watch this for a little bit, you're going to see that one zone drop to like a 50% success rate. So again, not totally out. We're not, you know, experiencing an outage per se, but we're experiencing an application impact.
So let's go ahead and fix our warehouse, get everything back to normal, remove Topology Aware Routing again with the simple annotation of removing it, and check our work. Again, simple grab, it's no longer there. We can see in the vents that it's been disabled, just as we expected. One thing you may encounter is just a complete failure. Something happened where everything's gone. So let's go ahead and just delete our Boston warehouse.
We're going to use the big hammer.
Just bam, gone. So let's go look at our endpoints. Now we're missing endpoints. We no longer have our 9 endpoints that we are required to have for Topology Aware Routing.
Yeah, and this is pretty extreme. We talked earlier about, you know, wanting to have enough endpoints to spread, you know, to not meet your quorum, right? You want to make sure that if you're going to use this, you spread that load wide enough that if you just lose a few endpoints in the zone, you're going to still have enough endpoints to keep Topology Aware Routing active. We're kind of on the extreme side here, right? 3 endpoints per zone is the minimum, and that's what we chose. But we wanted to be able to show failure conditions, you know, clearly in a quick manner because we only have 35 minutes, right?
So what's the status? We're going to use, again, Linkerd viz to be able to view this. And we can see everything's being spread across. Our success rates are still high because things are going to the other workloads. So let's go ahead and restore Boston.
Yeah, this is a little different than the other ones because we want to show you the failure while Topology Aware Routing is engaged, because if we were just to engage it, it would just pop right back out, right? That wouldn't be any fun.
So now we can see everything in Grafana starting to stabilize. We still have our cross AC traffic going on.
Mm-hmm.
So let's go ahead and add Topology Aware Routing now. Again, simple annotation. We're going to double check our work, make sure everything's good, which it is. Look at our events. We can see that, oh wait.
And before we do anything, just remember, right now we haven't hit it with the hammer yet. Topology Aware Routing is engaged. You know, if we let things run a little bit, we're going to see that we're going to keep traffic in zone until we pull out the hammer.
Let's go ahead and list our endpoints. Now we have all 9 as expected. Let's go ahead and look in Grafana how that looks.
And you can see the red line is going back down to 0. We're keeping traffic in zone. We're avoiding costs. We're avoiding cross AZ latency. Life's good. You know, if we let this run for a second, I think we got a second here.
Yeah,
we do.
Seconds, yeah.
We can see that that's going to go, and then we're going to pull out our big clown hammer, and we're going to hit this zone in the east here, take out the service.
Yeah, so our boss, Gary, decided to go take a stroll through the data center, and he's tripped over a cable, and the whole thing just went down. So again, whole data center is down because, you know, someone went through a stroll in our data hall.
So we didn't have enough power leads.
Yeah. Again, now we don't have our 9 endpoints. So how did it react to that? So let's look at our events. And this is where Tom was talking about how sometimes in events, you know, I think who here is familiar with events and sometimes how it, you know, likes to shove them together where it does it. Anyone experienced that with events? And I know people have, yeah.
Yeah, it took a little while, you know, as we're developing this to kind of get a feel for, you know, what these things meant, right? And another important thing that, you know, I cut out because of interest in time is it's important to note what version of Kubernetes you're on, because these things are still beta and they're going to behave differently. And we actually, Flynn in the back hooked us up with the folks who, you know, do Topology Aware Routing, and we asked them some questions and said, yeah, you know, it's going to be best to be on the latest because these things get improvements as it goes. So make sure you read the documentation and you understand what the status of some of these features are, how to enable them, you know, if you have to do extra steps, and, you know, how they're going to react and where to look for things, right?
Let's go ahead and look at our status in Viz again. And we can see that right now, everything's working. Let's go ahead and look how it's in Grafana.
Did we enable topology aware routing?
We did. It should have been, should have failed.
Did it kick out? It did kick out. So it looks kind of odd. Go back to Grafana, right? So when it kicked out, Linkerd took over, and we're right back at that default state of that 2-to-1 traffic. We didn't get the event, but what we're seeing here is exactly what we would see, in a status where, where we wouldn't have topology aware routing enabled. Now, we didn't get the event, but we can still measure using observability, and this is why it's important. It's not always going to be clear if this thing kicks out due to endpoints. At some point, it may put an event in there, but in my experience, it's been kind of spotty, right? And I'm not bagging on it, but this is just one of those realities that I'm sure we all deal with, is that it's never cut and dry 100% of the time, whether something's working. Having observability, having metrics, and being able to leverage those things is really key to being able to have success with some of these features in Kubernetes.
Go back. That was the complete second one. Let's go back to our slides. Sorry, fam. My laptop decided to go all over the place for me.
All right, so all's not lost. What do we observe here? Kind of what's the takeaway, right? We explored like two options. Without topology aware routing, we're going to pay for cross-AZ traffic, right? With just default Linkerd, it's going to give us some reliability and some redundancy, but we're going to pay for cross-AZ traffic. With topology aware routing, it's a just straightforward, easy to deploy way to do connection-based routing and avoid cross-AZ traffic. But there are certain types of failures that you have to be aware of and manage and mitigate. And having observability, having metrics, and having these external mechanisms that are aware of things like layer 7, routing and the conditions that go through there in your in-band failures really is an advantage, right? So, you could end up, if you're not setting up the proper observability and watching what's going on, you could end up worse off than than just paying for that traffic, right? So you have to have a lot of design considerations in place, and you need to be able to watch what's going on. So conclusion, right? Great tool for keeping traffic in zone. It's very straightforward. It's very easy and quick to enable. You could mitigate some of the stuff yourself if you wanted to write, an operator or something that would keep an eye on success rate. So say you have observability and you go, all right, if success rate drops below this, I'm just going to turn topology aware routing off for now, send an alert, and then we're going to go check it out. So there's ways you can mitigate it. It's going to involve some work on your part. It's going to involve some maintenance on your part, right? And making sure things are behaving the way you want. Using a service mesh for observability is huge, right? It's a great complement to topology aware routing. And that, failures that are inbound failures or things that don't remove endpoints are not going to kick topology aware routing out. So you need to deal with that yourself, and you need to be able to watch things. So the shameless plugs. We have a product that we run internally. It's Buoyant Enterprise for Linkerd. It's OSS, the great stuff that you love in there. It's got some additional things. We've got zero trust security, global traffic management. We can watch all this layer 7 stuff that we care about. We do some hardening, and we've got some advanced zone-aware load balancing in there as well that is request-based, versus connection-based. You can go check it out. You could stop by the booth, talk to us, and we'd love to answer questions, about some of this stuff. It's our passion. We got some sessions coming up. We are this one on Thursday at 11, but we've got 3 more sessions coming up. Please go check these guys out. They are fantastic speakers. They are much more experienced than we are. They're not up here sweating themselves to death, wondering, what's going to happen. And we didn't have that many failures, so you lost your bets. Meet us at the kiosk. Come by, check it out, get some goods, and have a conversation with us. We'd love to talk about Linkerd, talk about your apps, and how we can make your life better.
We got some cool T-shirts like ones Tom's wearing, with Linky and Ferris on there, which is the mascots for Linkerd, and then Ferris is the one for Rust. If you're not familiar with Rust, it's the proxy. It's a quick.
We're a Rust-based micro proxy, security, fast, light footprint. And thank you. Thanks for coming out. We appreciate it. I mean, you guys are the folks that keep us doing what we do every day, and enduring the suffering. Any questions? If you have a question, feel free to step up to one of the microphones. We'd love to answer it.
Everyone's going to go get their lunch.
Yeah.
That's where everyone's going.
I'm assuming it's lunchtime.
There's no dumb questions.
What do you use for the demo that type?
It was called Demo Magic, but we have a better one that we use called Demosh, and it can be found on our GitHub page.
Okay.
You can
And
talk to
it's-
Flynn
and
about it.
This is the master of it.
So the question was, what do we use for our demo, our CLI demo?
Yeah, he made me very sad, like telling me that
He almost yelled at me.
his laptop Python got screwed up and he couldn't install that.
It was user error with my Python.
Python.
So, yeah.
Python problem.
Yeah.
GitHub.com/buoyantio/demosh is that tool.
And it's a lot more powerful too. It's much better. This one was a little barbaric.
Demo magic is you write shell scripts and it gives you commands to say things like, I want you to print this and then execute it. Demosh is you have a markdown file and it executes things in bash blocks and prints them as an argument. Okay. So the markdown file becomes the executable for the demo.
Yeah, and that was our goal, was to be able to lift this stuff right out of our README and whatnot. It's just, the timeline for getting it working and fixing Python took a back seat, right?
Demos are hard, but we wanted to do it live with command. And there's a lot of commands. I can't remember all those.
Oh, yeah.
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 Check it out. Yeah, it made this actually work, so I wasn't so nervous. If I was going to up here and watch everyone like mistype kubectl commands all day, I would have been really judged. So.
No chance. That's never existed.
No.
Nope.
No.
Thank you.
Oh, thank you.
Thank you.
Yes, thank you.
The dashboard you showed, is that like a Grafana marketplace?
That is not, but if you go check out Buoyant.io, that's us, on GitHub, and you look in the repositories, there's all kinds of cool stuff out there. We've got a Service Mesh Academy that we do every month that Flynn and I tend to host. And there's some great resources in Service Mesh Academy. Some of my repositories that this is based on are out there. We've got some different playgrounds. If you search for playground, you'll probably see my stuff. Pardon me, the READMEs tend to be 80% complete, but the automation works and it allows you to get hands-on using K3D clusters on your local machine. Yeah, and that's my personal one, but I've got some stuff out there too. You're welcome to root around there if you want. But Buoyant.io, yeah.
Yes.
Yeah, it's going to keep, yeah. So in our case, right, we had the minimum number of endpoints. All it took is one endpoint, but that was really about, being able to trigger it reliably and quickly in 35 minutes. But that's why I said spread it wider, have more endpoints. If you have to make your services or your actual instances a little bit smaller, but spread it wider, it's going to prevent, like if you just lose a couple endpoints here and there, you're not going to kick out. And again, depending on your app, you might want to, right? If you've got some app that it's important, like if I lose one endpoint, the world ends, then you probably want to do that. But it's all about design. And the other thing that, if you read the documentation, they'll tell you what the weaknesses are. They're very honest about it. And one is that, you tend to want to have very stable and well-distributed traffic. If things fluctuate, if you want to put this thing together with horizontal pod autoscaling, and again, not to beat up on anybody, you can get some interesting results because things will change and you can get where the two things are interacting and it's a little bit crazy. Yep, it's request-based routing, right? So we're looking at each request and we're making the optimal decision based on that request. So we can react in real time, and that's why. And again, topology aware routing, works great. It's very simple. It's just, using observability with it makes it more reliable.